pay for all this climate change stuff. It's like, we are, no matter what you say, we are. Anyway, so why don't I get started, since it is about 5:30. In this agenda, I try to keep you awake. I'm going to be talking about ocean changes from global warming, and that'll be about a half an hour. Then I wanted to talk about some actions. First thing is EPA's proposed endangerment revisions. If you're not familiar with that, we can talk more about them. Also, we talked about connecting with other like-minded groups to try to increase our numbers, or at least increase the number of people we can work with. And then, it sounds like we already know the last bit, but talking with Brookings Mayor.
City manager.
City manager, there we go, okay. And then the next meeting. So with that, let me see if I can change here to the other presentation. And we'll start with that. Okay, so you're familiar with this, that's me. So from your perspective, what is the most critical impact on the oceans from global warming? What would you say is the key one?
The loss of fish.
Loss of fish, for a variety of reasons. There's a seat right here for you. It's nice and warm. I was sitting in it for a while. Welcome, Marina. So, what else? What are you aware of with that?
Coral reefs.
Absolutely. I think that's for me as a marine biologist and a coral reef biologist, it hurts a lot. What other things have you heard of? What do you think of?
Acidification.
Acidification's got a lot of impacts, yeah. So, but we'll go through some of those, talk a little about the causes and all. So I was going to first talk about ocean heating and what the consequences of that is, and some of the effects, the extent of what it is, and also ocean acidification, why it's there, some of the chemistry, and what some of the effects are. So you probably have seen this before. The global surface temperature has gone up and up, and 2023 was the hottest year on record until 2024, at which time that was the hottest. And we'll see what 2025, as I've been told, estimates probably number 3. Certainly it's going to be in the top 10. In fact, the top 10 hottest years have been the last 10 years. It's a heck of a record to keep going. But Earth is a water planet. 71% of the surface is covered by water. So it's actually a pretty good thing, as we'll see in a minute. Now, if you look at where all this global heat has been trapped, the atmosphere, you can barely see it down there, but it is there. If you look at the land, because of the heating of the land, it's got a little bit more than in the atmosphere. You look at the ice, which is largely the heat that's been trapped by melting the ice, it's a bit more. But then you get into the oceans. Now, 2,000 meters is very deep ocean. I mean, it goes lots farther than that, but it's not very well studied. Between 2,000 meters and 700 meters, the 700 meters is about the twilight zone. It's about where sunlight doesn't get beyond. And so there's a fair amount that's been trapped there, but from there to the surface, a massive amount. Now, what's even concerning more is that half of the increase has happened within the last 10 years. So it's heating up, and it's heating up rapidly. Now, it's interesting, the suggestion is 93% of this extra heat has gone into the ocean, which somebody had made an estimate of that. The average temperature of the Earth is roughly 59 degrees. If there hadn't been an ocean there, we would be, on average, 63 degrees Fahrenheit hotter. In other words, the average temperature would be 122 Fahrenheit. So very fortunate that as a water planet, it's kept it just to the limited amount that we've had so far. Now here's the ocean temperatures, and this is from 1950 all the way up to now. And you focus on the right side of it, you see that there were these peaks that corresponded to the El Nino. El Nino is when you have the warming trends, and that's when water temperatures are higher. You can see La Ninas are lower, but still the trend, even current La Ninas are hotter than past El Ninos. Now, if you look at ocean heat content, how much energy is in there, and this is the average for the decade between 2013 and 2023. Now, in 2023, you see some peaks. 2024, exceeded that. I mean, they're pretty well above the average. This last one, September 26th, was interesting because it's on September 26th that the Hurricane Helene was forming. And it was on its way up to Florida. And it's kind of interesting because it's a massive hurricane, really big, but really amazing that it on September 26th at 6 in the morning, it was a Category 1. The next day, by noon, it was a Category 4. Now, the problem with that is people don't have enough time to make preparations, to evacuate, to do things that you would normally do, because they go, Category 1, we've been through that a lot. You got a day, and all of a sudden, it's much worse than that. So that's a real big issue. And then it landed on shore, went on up, and there were areas with more than 10 inches of rain in places. Picked out Asheville because that was an area, it was Yahoo News, I believe it was, that ranked the towns or counties in the U.S. By the way, Curry County was ranked the lowest, the county that was least likely to be affected by climate change in the Pacific Northwest. Asheville was noted as being a city that was among the lowest chance of being affected. Asheville almost disappeared because there was such massive flooding. It was the flash floods and everything, very, very devastating, and they're still trying to fix out that. So from the extra heat, a variety of things are happening. We have physical changes, to look over on now. That means increasing evaporation. The more heat there is, the more water is going to be evaporated out. More moisture in the air and more energy in the air. We're going to see that there's more intense, more rapidly intensifying storms, like Helene. It's a very big deal if you can't prepare for things. Slower moving, longer lasting storms. As the winds are changing, they don't go move the storms along as fast, so they got a lot of water, they rain and rain and rain, then you get more and more flooding, which just makes sense. Okay, so at the same time Helene was forming in the Atlantic, or in the Caribbean, the Hurricane John was hitting Mexico's west coast. There's Acapulco there. It was interesting because a year earlier, an even larger hurricane hit Acapulco and devastated it. In fact, the winds were a Category 5. They intensified by 150 miles per hour in one day. You go from a Category 1 to a Category 5. If you saw pictures of Acapulco, it was just destroyed. Again, you don't have time to do anything. You have sea level rise. You've heard about that. It comes from melting glaciers or big sea or land masses, ice masses on land, like Greenland or Antarctica. You have also the other half of that, as water is warmer, it expands. So the amount of sea level rise we've seen so far is about 50-50 in round numbers. Now, most of the projections you see are in the next decades or at the end of the century, with certain exceptions. If things didn't quite get it right in how fast the glaciers on Antarctica are melting, or how the Greenland ice sheets are stable and how they're melting, it could accelerate a lot faster than that. It is interesting here that we don't really have that much to worry about, because the suggestions, the projections are that we wouldn't see much in the next few decades. We'll probably not be around in the next few decades to really find out. NOAA had prepared this interesting, sea level rise viewer, and thought, all right, this is what it says for an average mean higher height water, the normal high tide, and it doesn't show with 2.5 feet a whole lot. Maybe some of the beaches are shorter. Well, that's straightforward. If you go up to 5 feet, you might see up the Chetco a little bit. If you go up to 10 feet, well, that's going to be a long, long time from now. And we don't see that big of a change. Go to some place a little bit farther north. Coos Bay has a lot more estuaries and more areas there. Back at what it is right now, you can see that, well, mainly in those green areas, there's going to be wetter. This up here is in the middle of the island, so that stays what it was. But we got here at 5 feet, you can see more areas that are consistently wet, and there's the wetlands around Coos Bay itself. At 10 feet, well, we lost the airport, lost basically all of the north jetty, And so that's but that's likely to take a long time. But I don't know that you want to be investing in the next decades in the areas up there. Now, is there any place that you would be interested in seeing that sort of projection? Say that because here's a really interesting thing that NOAA has, at least right now, until climate change is wiped off the government servers. But where would you be interested in what sort of sea level changes there would? What city?
Harrison, Idaho.
I probably can say without much concern that it's not going to show a lot with sea level rise. What about?
Olympia, Washington.
Okay.
Or Crescent City, which is a little bit more flat.
Okay, let's see. Crescent City, USA. All right, that's what we have right now at normal. How about 2 feet? Doesn't really show that it's going to be affecting that much. How about 5 feet? Well, there's some areas that are going to be affected. It might be, see if we can pull it down a little bit. Some areas, yeah. So that'll be more. So that'd be a bit of a concern. If we do it 7.5 feet, it's going to get a lot more. If we were to go 10 feet, so yeah, there would be a lot of effect there. But because it's fairly high relative to that, but again, it does not take into consideration storm surge. So when you have a big storm, that's going to be 2 feet, 5 feet on top of, already the storm surge is going to be sitting on top of that. So right now, if you walk the beaches here, you can see that those heavy waves in a winter storm can go way up the beach. Add 5 feet to that, and you realize that that's going to affect the coastal properties pretty significantly. Any other cities?
Miami.
Oh, Miami's a good one. Oh, come on. Miami, Florida. Or I did that one already. That's at 10 feet. Well, let's just drop it back down to a mere 5 feet. And that's the airport. So, and again, with the hurricanes and a 15, 20 foot surge, they already, and there's no Miami Beach there.
Did you say Olympia, Washington?
Yeah. I don't know how their waterways are affected by ocean, though.
Yeah, I have a feeling.
They're right on the Seattle, whatever that
Olympia,
body
Washington.
is. Yeah, Puget Sound.
So this is, let's go back down to the current, and that's the areas we'd have. Let's see, move it down a bit. And let's jump up to 5 feet. Doesn't look like it's having that much of an effect. 10 feet, it's going to be moving it in a ways. There are some other low spots that would be affected. Here is the 5. So again, because of the steep terrain, it's nothing like the East Coast. So let me see if I can get back to the presentation. Let's see.
Oh, wait a minute, are they on the coast? Or maybe
Yeah,
it's Galveston.
Galveston's on the coast.
Galveston.
Galveston got destroyed by a hurricane back in the turn of the century, I think it was. Other century, possible.
Yeah, so here's Galveston. And let's look out a little ways.
Get the song when I hear them.
Yeah.
Mm-hmm.
And let's see, how about a 3 foot change? Ooh, that's going to have some real problems. 5 foot change. But Galveston doesn't ever get hit by hurricanes, does it? Sorry, I know that. So yeah, you can see a lot of the coast down there is going to be really affected. So that's Texas. And Houston is up here somewhere. There's like Charles. Yeah, so you don't map that stuff. Or Idaho.
This is 5 feet what they're showing up?
That's 5 feet.
And when would that happen?
Was that?
When's it projected to happen?
Well, it depends. Some people say it could happen within 2 to 3 decades if the Antarctic ice sheets start melting. Other projections, it's going to be the end of the century. So
So the way I was thinking about investing in dryland property now, that would be waterfront property soon, but that's not soon enough.
probably for your grandkids for that investment.
Well, we balance it to
Always thinking about yourself, all right.
Okay, another thing that happens because of the extra heat is changes in ocean currents. Now, you may have heard about the Atlantic Meridional Overturning Circulation, the AMOC. Now, the interesting thing about that, that's all part of what's the thermal haline circulation. I got schooled on this when I was doing an oceanography class a few years ago. And it was really amazing because the early oceanographers went all around the world and sampled the water, and they were shocked. They were surprised that there's an amazing amount of uniformity in the different physical characteristics around all the oceans. And that's because of this thermal haline circulation. As you kind of see with this, water gets moved around and then goes around all the way around to the different oceans. And so it's a good thing because it helps distribute nutrients, heat, various other things like that. You don't have the stagnation. Now, if we look more closely at the Atlantic Ocean, that's the AMOC they hear about. And it's really interesting as the water, surface water goes along here, it's going to be fairly hot. It's also going to be evaporating. So it's going to lose a lot of the water, but it leaves the salts behind. The more salts, the more dense it is. It's nice and warm. It stays to the surface. As it goes up there, as it gets higher up, it loses that heat, but it still has the salinity in it, so it gets more and more dense. By the time it gets up to the areas up in Greenland, it then is denser than the surrounding water, and it sinks down. That sinks down, goes way down, goes all the way to the bottom of the Atlantic Ocean, down to the bottom of that area. And as you saw in the previous slide, it takes a circle all around the world. Now, that's good if things work right. However, some of the studies, and I'll show you a little bit of a picture in a second, that it's losing its stability. And if it loses its stability, either how fast it goes or if it stops entirely, there's some significant problems with that. Now, here's a picture that depicts the current temperature increases on the Earth. And that little blue spot is the oddity, because why in the world is it not hot like the rest of it? The suggestion is that the Greenland ice sheets are melting and letting cold water come into there. That cold water is going to be fresh water. It's going to be sitting on the top. This is used to having the water up there being dense and cold and sinking down. Well, this is mixing with that, or it's making a layer. So that slows things down. Now, it's kind of interesting when you look at this. That water, that heat, is coming over here and keeping a lot of Europe nice and warm relative to what it would be. That Barcelona and Chicago are on the same latitude. So if you've been a winter in Chicago, it ain't like Barcelona. Trust me, been there. Calgary is even worse. And so it can tell that if this slowed down, if this energy, this engine pushing warmth up to Europe were to slow down, Europe would get much, much colder. Of course, that heat's got to be somewhere. It's going to stay down here, so other parts are going to get much hotter. And that just throws a whole balance off. So who's to say what's going to happen after that? So those are overall changes to the currents. What about locally? Yeah.
Was that part of it, when we talked about this before, when the waters in Florida got like 100 and some degrees?
Yeah.
Is that part of that whole thing?
Oh, yeah. Well, it's a combination of the waters going across the Atlantic through the Caribbean and the Gulf of Mexico up by Florida. There's a lot of time be on the surface and heat up. So, yeah, it's all part of the overall systems. So localized changes in wind, that's of interest here. And the concern is it could upset the balance of upwelling. So again, we've got systems that are very well tuned and really adjusted to how things are. It's kind of a nice baseline. But if we start tweaking things, or if things start changing, things don't work as well. How many of you are familiar with upwelling? Have a good sense of it? Okay. Yeah, so it's really nice because when the summer winds blow down the coast, it means it's pushing the water along. But the interesting thing in the northern hemisphere, water will be pushed off to the side. Just sort of think of a crowd of people as you're pushing and somebody going to be pushed off to the side. And that's because of the Coriolis effect. It can't go to the left because there's the coast there. So as it goes off, its warmer surface waters have to be replaced, so you get deeper, colder, nutrient-rich water coming up. Now that's been out there for a long time. It's not real high in oxygen, but it has lots of nutrients because they've all sort of rained down. That's great because the phytoplankton use that, phytoplankton get eaten by the zooplankton get eaten by the fish and such, so that we have really, really good fisheries. Now, the concern is that here is how things are sort of standard. The low pressure cells, it's warm here, it's cooler off there. We have the wind stress going here under right balance. If the heating happens inland, it causes more winds. The more winds you have, the enhanced greenhouse gases, we have the wind stress increases, so we have the offshore pressure being that much higher. It'll be increasing the upwelling, which isn't necessarily a good thing because it's finely balanced. With that, it can lead to increased algal growth, which may or may not be good. If it's not in balance, we can have algal blooms. Algal blooms can lead to eutrophication, which basically is just over-fertilization. They get in massive numbers, the algae in massive amounts, and that can cause some problems. It can result in low oxygen or no oxygen zones, which we'll talk about in a second, dead zones. And one of the reasons this became a big deal very recently is with the offshore winds. The suggestion was that, you put these turbines out there and they're harvesting that energy. That means there'll be less wind energy to move the water, less upwelling. Jack Barth actually last January gave a talk here on upwelling and it's a very good job. He's an oceanographer from OSU who's been studying this for 20, 30 years. He gave a very animated talk, really interesting. And he said that from what he was able to tell, the effect was going to be balancing out, maybe. Certainly it's on the same order of magnitude or greater, in that there would be more upwelling due to the increased winds than would be lost from the harvesting of the winds by the turbines. But it was in, close sort of thing. With the local data, and this is very confusing, I'll admit, but here they said just for a measure, looking at the days that were above 90 degrees in Portland. So over time, going from 1980 up to 2024, you see that there is that trend, and there are more days with 90 degrees, above 90 degrees than there were decades ago. That's one piece of data. And that then, with the extra heating, leading to more stronger winds, we do see that the wind stress is greater. That means that there is more upwelling. So based on his data from the last 20, 30 years, there is, in fact, more of the upwelling going on, which is leading and explains some of the issues that we've got with eutrophication. Now, there are a lot of dead zones around the world for a variety of reasons, largely because human activities jumping nutrients into the water, causing the dead zones. Locally, in 2002, Oregon first saw our dead zones. Now, it's a regular event. The worst was 2006. 2017, 2018 was the most recent, and they were pretty substantial. So these are, they call them the dead zones. They don't really like the number that, but in fact,
some can swim away. Some try to crawl away. Others might propulse away. Many are just too slow or stuck.
Dead zones of low oxygen water kill crabs, fishes, and other marine life. And the recent annual occurrence of dead zones in the nearshore points to dramatic changes in our ocean environment.
So it's interesting because they have been following this now, and as they said, if you can run away, then that's great. If you're stuck there, like clams and things that can't, or crabs that can't go fast enough, then they're going to die. It's just going to have some significant effects on harvesting of the animals. Now, in addition to all this, we have a reduction in sea ice. As the sea gets warmer, you can see for 500 up to 2,000, the amount of ice in the Arctic based on some of the cores they've done, and so it's a pretty good record back there until now. If the extent of ice was, say, 10 10 million square kilometers, and now it's about half. That's a hell of a loss of sea ice. Now think about it. If you have ice that's there, the sun shines and it reflects most of that energy back out. If that warms things up, the ice melts, now there's more open water. More open water, that absorbs it, and that reflects or it re-emits the kind of wavelengths that will be captured. So it's a reinforcing feedback loop, only it's a positive feed loop. The more ice gets lost, the warmer the water is, causing the more ice to get lost, causing more warming. So that's one of those feedback loops that you might have heard about, maybe a tipping point. And you can see that we've lost an awful lot of ice already. In addition, we can see localized heat waves. And you might have heard from when we had, it was 2 years ago, the massive heat wave on Pacific Northwest, and you see some of the pictures of the intertidal animals that died. It was quite significant. A couple of months ago, the New York Times did this really interesting graphic representation, and it showed these areas that were experiencing a heat wave. Now that heat wave, let's say go back in 2000s when they started it, beginning of 2000, said 4%, a little bit over 4% of the world's ocean surface was experiencing a heat wave. Now jumping forward about a decade, it then was up to about 4%. So not a lot until about 2016 when there's this massive spike. It's been referred to as the blob. It's off here, had a massive effect on the local fisheries. A lot of people were happy because there were fish that normally don't come up here. We're up here for fishing. But it also killed a lot of things, and it was affecting the amount of algae, algal blooms, and toxicity, things like that. Continue on. There we go. In February 2024, let's see if I can get back one. Yep. There, June 2022, it was down to about 20%. By February 2024, it was more like almost 40%. So going from 4% in a couple decades to 40% is a big, big deal. Not only do the warmer waters favor, cause other things, but they favor the toxic algae blooms, and they add into the formation of the dead zones. Got a bunch of things going on with this, clearly. Now, those are sort of around the physical changes, the heating. The chemical changes are not trivial. Now, warmer waters hold less oxygen. So if you're already kind of oxygen stressed and the water temperature will go up, you're going to be even more stressed for two reasons. There's going to be less oxygen in the water, and probably your metabolism will go up as well. So you're going to have even more stress from that. That adds to the hypoxic and the anoxic zones, the dead zones, sort of being a bit of redundant here. And then also chemical changes are acidification. We'll talk a little bit more about that shortly. Now the biological changes related to the marine heat waves are significant. As we saw with the video, mobile animals will move away if they can. The stationary ones will be in trouble. Now the mobile animals may be moving to cooler waters if they can, or it may be that animals that are in used to tropical waters will be moving into new areas that are now warm enough for them. Now that can disrupt breeding cycles, food webs, migrations, various things like that. So biological systems are going to get messed up. 40 to 60% of the fish are at risk because they're too warm for the spawning and embryonic stages. The youngs are when they're at most risk. And so if you can't get the young spawning, you can't get the spawning to happen, you can't get the young to survive, you're having no adult fish to continue on. Like I said, many take advantage of the warmer waters, move to new areas. There's Dorado, which is mahi-mahi, or you might have heard of the dolphin fish. They are not dolphins, they are fish. Mahi-mahi are good for fish tacos, among other things. Others will seek the cooler water, some go deeper. They'll head to northern waters, which is, if you're a fisherman here and your gear is set up for getting things that are used to being found here, you may have to move with the fish, which many fishermen will do anyway, but then that disrupts other things like family life and your harvesting, who you offload your fish to, and various things like that. One interesting aspect about that is that there will be new fish species that will be here, and that what we need to do to adapt to this is finding ways of cooking those fish and making people to like new types of fish, be interesting types. Not only is it our prey that we're looking for, it's the predators. That's a Humboldt squid. You can tell by the size of the diver, that's a pretty big squid. And they are voracious predators. So if they move into an area that the fishermen are going to be normally capturing those fish, but the squid are up there in big enough numbers, that may just decimate your fish. In addition, it seems like gelatinous animals are more common. Jellyfish are increasing, suggested to be significantly. There are some things like this pyrosomes or sea pickle, which are actually more related to us than they are to crabs or lobsters, which is interesting. But that's a whole change in the ecosystem, which would have real problems for us. So, other things or migration things could change. Temperatures give different signals. Either the adults will delay going up the streams, they could get caught in storms. The smolt won't leave the streams at the right times. They may leave early, and if they leave early and they're used to a certain type of fish or a certain amount of algae or other food out there and it's not there, that's not going to work if they're not fully developed. So there are significant impacts like that. On a somewhat different note, we have sea turtles whose sex is determined by the temperature their eggs are developing in. Northern end of the Great Barrier Reef, 99% of all young green sea turtles are female. And that's because the water's too hot to allow for the development of males. Plants and non-mobile animals die, as we've seen. That leads to can lead to coral bleaching. Now here's an interesting graphic from, I did it in the 10th of April, and it shows coral bleaching. Here is no stress gets to that. Notice this part of Australia. That actually has a reef that is every bit as fantastic as the Great Barrier Reef on the east side. But that has seen roughly 95% of its corals have experienced bleaching, and they're concerned about it. They'll be in deep trouble. You can see off the the west coast of South America, that's the Galapagos right there. So it's going to be stressing a lot of places. That was a single point. This is the suggestion between April and July this year. And you can see, again, that part of Australia, this part of Indonesia, all these areas are going to have a very, very high chance of extreme impacts. Now, the coral bleaching is of interest to me. I mean, I spent a bunch of time over there in the Virgin Islands, and that's where I got to love coral reefs. And here's an interesting animation, if it'll go. This is over 10 days, so starting early August. Actually, I'm going to get to go diving right about there at the end of, for my birthday next year. And yet, I'm concerned that the corals will not be there. And I've dived in places where the corals have been decimated, and it's not much fun for a coral biologist, I'll say that. So, bleached corals. Great Barrier Reef's lost half its corals over the last 30 years, increasing. They continue to have bleaching events. It's one thing to have it happen, then enough time to recover from it. But when you can't recover, it just repeated impacts. Okay, there we go. So in addition to the marine heat waves, we have increasing algal blooms, the red tides, we have the domain acid. How many are familiar with domain acid? So it's not good stuff. Domain acid poisoning is a neurotoxin. Domain is a neurotoxin. Its symptoms are gastrointestinal disturbances, seizures, memory loss, or rarely death. So it's not good stuff to have. It is more common and more toxic in the warmer waters and waters that are more acidic. So we kind of have a double whammy coming with this. It has a big impact on commercial and recreational harvest of animals. In fact, 2 years ago in February, 2 years ago, the opening for harvesting Dungeness crab was pushed back to February, which means you've got a very short time window to do your harvesting. The razor clams are routinely closed. Any of the other filter feeding clams are closed. Mussels, if you harvest mussels, you have to pay attention to that. The Oregon Department of Agriculture tracks those, so you can, if you do go out, harvest, do foraging, be sure you check on those. Now, the domainic acid is produced by diatoms, that's a particular species, Pseudonychia. So the clams filter the diatoms, and the clams concentrate the toxin. Crabs eat the clams, and they concentrate the toxin. Now, a good thing is that the crabs it takes a long time for the toxin to go from their gut to their